All right, 1.6, the last section of Unit 1, solving for a variable and applications. So our objective is to given the formula, solve for a different variable, and also do application problems. All right, so if we want to get the variable by itself, which we've been doing for a while, we need to get this alone. All right, so the first thing we do is get rid of the furthest thing away, which is the 4. And that gives me negative 2a equals 6. And then we're going to divide by negative 2. So a is equal to negative 3. Okay, that's just a basic algebraic solving that we've been doing for a while now. Now, sometimes you might have more than one variable. So you can't just say solve for the variable, so we are going to tell you solve for a certain variable. Now, pretend the x was not here. Don't cross this off, but just pretend that wasn't there. All right? Look familiar? All right? We would subtract the 4 and then divide by negative 2. Just because there's an x there does not mean anything differently. We still need to get rid of this. This is a positive thing, so we need to subtract it. Now, the most common mistake here is to say 10 minus 4x is 6x. You can't do that. Notice how I didn't put the 4x really right underneath the 10, because they do not join together. They're not like terms. One's a number, one's a variable. You could have also written 10 minus 4x, but with what we're going to do this year, we often want to have it in this form where the x is first, but it wouldn't be wrong if you put 10 minus 4x. And then we divide by negative 2. Everything divided by negative 2. That cancels, and we find out that y is equal to negative divided by negative is positive, and then a positive divided by negative is negative. And you might remember from Algebra 1, that's in slope-intercept form, whereas negative 5 is your y-intercept and 2 is your slope. All right, again, we're solving for y. So, again, we're going to subtract this 3x. I'm not putting it under the 7, just to kind of illustrate that it doesn't go together. So that leaves me 1/2 y equals negative 3x plus 7. And again, 7 minus 3x would be okay. Now, I know you go, well, 1/2 is being multiplied, so we divide by 1/2, which is technically true. And if you type it in your calculator that way, it's going to work out all right for that, but not over here on the right side. So let's instead multiply by the reciprocal. See, that cancels. You can technically do a 2/1, but whatever. And then we need to multiply this whole side by 2. So therefore, we need to put that in parentheses and then distribute. Whoops. So that gives me y equals negative 6x plus 14. And again, if that was a line I was graphing, I'd start at 14 and have a negative slope of 6. Now, what if I have nothing but variables? And it says solve for p. Well, I need to get this p by itself. I like to circle the one I'm solving for just to keep me focused. Now, what is attached to the p? Well, technically, this is I equals p times r times t. Or you could have parentheses or whatever. But this is all multiplication going on. How do we undo multiplication? We divide. Now, we could get rid of each one in one at a time. Like we could divide by r, and then simplify, and then divide by t. But we can do it all in one fell swoop. Just like that. The r cancels, the t cancels, and p is equal to I divided by the product of r and t. R times t. And it would be the same if we were solving for r. You just switch the letters. Okay? Real quickly, r would be equal to I over pt. And t would be equal to I over rp. That's simple. Okay? Now, a little bit more work here, a little bit more going on. We're trying to get this y by itself. Now, there's a bunch of stuff attached to it. We have an x by addition, we have this 2 by division, and we have this c by subtraction. Notice how this is kind of all one thing. Let's get to that later. Let's get rid of the c first. So I'm going to add lowercase c. And pay attention to upper and lowercase. It does mean something in real world applications. So that means a, capital A plus lowercase c is equal to x plus y divided by 2. Well, to get rid of this 2, we need to multiply by 2. We do the same thing over here, but since there's more than one thing, we put it in parentheses. That cancels. So I have 2a, capital A, plus 2c, lowercase c, equals x plus y. And again, I'm trying to get y by itself. The x is attached. It's a positive x, so I'm going to subtract x from both sides. And that's going to give me 2 capital A plus 2 lowercase c minus x is equal to y. And for those of you who like to have your solving on the left side, solving letter variable on the left side, it's the same thing. All right? Either answer is fine. You do not have to have your variable on the left side. All right? Ooh, a little more complicated. A little more stuff going on. We got to get b by itself. So I'm going to get rid of one thing at a time. I'm going to get rid of this 5. So I'm going to add 5 to both sides. Technically, if you wanted to, you could get rid of the cx now because it's subtraction. But I'm just going to do baby steps right now. Y plus 5 is equal to bx squared plus cx. Now this cx is a thing unto itself. It's a group, c times x. So I can just subtract cx. That's going to give me y plus 5 minus cx equals bx squared. And last but not least, I need to get rid of the x squared because this is what I'm solving for. X squared is attached by multiplication, so I'm going to divide everything by x squared. Well, this is pretty much my answer right here. B is equal to y plus 5 minus cx together divided by x squared. All right. Like I said, if you want to, you could have, you don't have to write this down, but you could have done this all in one move and gone directly to here if you wanted. It's up to you. Whatever you're most comfortable with. It's best, whatever's best for your learning and your brain. All right, real world problem. So dry ice is solid carbon dioxide. Instead of melting, dry ice changes directly from a solid to a gas. It's the stuff they use in like haunted houses to create like fog. It changes to a gas at negative 109 Fahrenheit. Pretty cold. Use the formula to find the temperature in degrees Celsius to the nearest degree. All right, so that means since we're given Fahrenheit, we're going to plug it in on this side. If we were given Celsius, we would plug it in here. But we're given Fahrenheit. So we just write negative 109 equals 9/5. That's a C, not a 5. Got ahead of myself. 9/5 C for Celsius plus 32. Now, if you notice, this is really not different than what we just did. We're trying to get this by itself. It's got a 9/5 and a 32 attached. We get rid of the 32 first by subtraction. That's going to give me negative 141 equals 9/5 C. Now, here's the thing. We need to get rid of the 9/5. There's two ways to go about it. We can get rid of each number by itself, separately. All right? We can multiply both sides by 5. That would cancel the 5. We'd be left with 9C. And then we could divide by 9 and get rid of it. Or we can, in one fell swoop, get rid of both by multiplying by the reciprocal. All right? Which is 5/9. So if we multiply this side by 5/9 and this side by 5/9, okay, This cancels this out. And then we type in the calculator, negative 141 times 5 divided by 9 equals a temperature of 78.3 degrees Celsius. Okay, 78.3 degrees Celsius. All right, you buy a used car with 67,150 miles on it. You expect to drive the car approximately 12,500 each year. How many years will it take to reach 150,000? Okay. The car already has this set. That's a constant. That's how many miles are on it right now. Now, you're going to increase by 12,500 each year. And they want to know how long until you reach 150,000 miles. All right, once again, this number here is what we're starting with, the constant. This is the rate, 12,500 per year or each year. And this right here is the total. It says to reach 150,000. So at this point, this is no different than 5 plus 2x equals 10. We're going to just subtract this number. It's just larger. Like so. That cancels. We're left with 12,500 y equals, and we just type in our calculator, 150,000 minus 67,150. And we get 82,850. And then we divide by 12,500. Because that's what's in front of the y. So we divide our answer by 12,500. And that's 6.628 years. So approximately 6.6 years. About. Rounded. All right, the sum of the lengths of two sides of a triangle is greater than the length of the third side. If a certain triangle has lengths of 6 and 8, write 3 inequalities using the information given, then describe the possible lengths of the third side using a compound inequality. So it tells us right off the bat that the sum of these two is greater than the third side. We'll say T for third side. All right. Now, if you remember from geometry, if you subtract them, shoot, silly me, 6, the third side has to be greater than the difference of those. All right. So if I put those together as a compound inequality, I have T must be less than 14, and T must be greater than 2. And if you want to write them this way, you can. T less than 14, T greater than 2. So, T is in the middle. We put numbers in order that we read them. 2 and 14. T is less than 14, and T is also greater than 2. So it's any number in between 2 and 14, just not including 2 and 14. So that could be 5, 7, 10. It could be 2.01 or 13.99, but not 2 or 14. And that's it.